reducing downtime of a mine shaft or improving their cycle time or whatever you can have impact on that, it's tremendous because it's one of their production bottleneck. It can range from $25,000 an hour to $250,000 an hour for a downtime of shaft. So the ROI can be really, really big.
Today we're going to be talking about automation and underground mining. And I have with me the CEO and founder of PointLaz, Alexandre Grenier, who has an amazing technology that's going to increase safety, increase productivity, and make the inspection of mine shafts easier. Welcome, Alexandre. Why don't we start? Tell us a little bit about how we met. Do you remember where it was?
Yeah, I do. We were in NORCAT, the mining transformer event. So we were at our booth. You showed up, big orange suit, tall guy, and yeah, you stopped at looking at our system and had some questions, and I think we got along, and yeah, it was a nice event, and you decided to connect after that. So yeah, here we are.
Yeah, I really liked the event at NORCAT as well, and I had been looking at new technologies there, and yours was one that really stood out. So then I reconvened with my colleague, Trevor Kelly, who a lot of our members know, and he thought the same thing. He really liked the technology. And then what we discovered is that some of our members were already investigating your technology and working with you and had a lot of hope for it and thought it had great potential. So let's talk about it today. Tell us what PointLaz does.
Well, PointLaz, we're automating mineshaft inspections. So trying to reduce downtime and improve safety for the miners, increase also revenues for the mines. So we concentrate on shaft inspection because it's a really niche environment. It's a harsh environment. And we've put a lot of effort on making things work easy and fast in the shaft. So we've got plenty of things on our roadmap. Our first is our LiDAR scanner, which does visual and 3D inspection for the mines in under 30 minutes. So yeah, so basically that's what we do.
So what I understood from you is that mine shafts need to be inspected regularly. And there's legislation basically in every country that says how often it has to be done. How often is that? And what are they trying to do when they inspect a mine? Or a shaft, I mean.
Yeah, so it's pretty worldwide laws around the world that forces mines to do this inspection, which is a good thing. Makes the mine safer for both miners and also the operators. So what they usually do is you go above the conveyance, whether it's a skip or a cage. You attach yourself there. You put a little over top, so things fall. You might not get hurt, but might. And then you go down the shaft, and sometimes you have lights or not, and you go around and check if things might have changed. Give a little knock here and there with a hammer, and do a visual, subjective inspection for the mines to see if it's in good condition. So they can be either structural problems from the shaft going up and down all the time, and it can also be more geotechnical side of things where there's new cracks, new water leaks, new things that might happen in the shaft. So basically that's what they're doing. I've been in a few shaft inspections here and there. Sometimes there's miscommunication. It's really lots of potential hazards or injuries that can happen in these shaft when you do these inspections.
I believe you told me, I'm not from mining, so forgive me.
Yeah.
People do shaft inspections. They stand on top of the cage or the skip, and it goes up and down while they're standing on top of the thing.
Yes.
That seems super unsafe.
Well, they're attached at some point, and usually some hoists have some safety devices that doesn't let you go down at certain speed, but and you're communicating with the operator usually by rings. So when you ring 3 times, 332 goes down, 331 goes up. And this can lead to some miscommunication and can actually has hazards linked to it. So I was actually part of a near miss when this types of miscommunication happen and between the hoist operator and the actual miners going down and doing the inspection. So yeah, you're standing there, can be a kilometer up above you. If a rock falls, you might get protected or not. You can just lean your head to the side and check something. But if you're going down, sometimes you can forget that there are buttons coming up, so you can get injured here, fingers crushed or anything. So it's yes, mine shafts is a special environment.
But we have to do the inspections because we're worried about the mine shaft degrading, I don't know, collapsing, or somehow shutting down production. Is that why we're doing the inspection?
Yeah, exactly. So, well, first, you got sometimes 50 tons, 80 ton skips going up and down at crazy speed. They're guided by what we call guides. So they're kind of rails for the conveyance. And they're going really fast, and they have heavy loads, and there might be rocks falling, things like that. So it get wear down. So you need to actually track what's going on. And sometimes you have wooden beams, metal beams, so it can get wear down faster in some cases, and other cases not. So yeah, there's lots of structural wear that can happen and problems. If there's a skip door that isn't closed properly and goes up and just breaks different buttons going up. So the buttons are kind of the things that helps align the guides, and it can break them, or anything can really happen. You don't see in the shaft. It's you're totally blind where you're going down. So when they're doing their visual inspections each week, then they're seeing lots of different things. Rocks might have fallen and things like that. Now this is kind of a week to week problems that can occur, but on the long term, so mines or shafts are the infrastructure that's going to stay the longest in a mine. So for years, decades even. And at some point, ground can actually work and create some cracks, create some pressure. They eventually might have some rock bursts or things like that. So they need to check how the shaft is moving. And as you're mining stopes and doing some big openings on the ground, then you're affecting the whole structure, geotechnical structure, and this can even impact the shaft at some point. So you gotta have a good track on what's happening in your shaft, because if you lose your shaft, you kind of lose your mine, and it's not really good for the mines.
You lose your mine or you lose your mind?
Both, I guess.
Hey, so when I was a student, I was in second year engineering. I had a job in a refinery. And a refinery is kind of a dangerous place, just like a mine. So we had to do a lot of inspections. And because I was a student, I had to do this repetitive, boring task, which was every hour or two, go out through the refinery and read all of the meters, okay? But the meters were always the same. I worked there 4 months. They always read the same. But they were sending me out in case something had changed, right? And then we had to climb these stacks where they were processing oil. You had to go up this ladder, 3 or 4 stories high, which was a bit dangerous to begin with. But every hour you're climbing all these ladders. So I'm telling you, I was not the only one, but there was some of us who maybe sometimes didn't climb those ladders. Sometimes we didn't pay attention to the gauges because they always read the same. And now thinking about the inspection of a mine shaft, I'm not saying it happens, but I'm imagining there's these guys who every week, they're on top of that skip, they're doing that inspection, and they're saying, yeah, it looks the same as last week, and maybe lose a little focus, maybe miss something. Is this an opportunity for automation where a robot could replace a human and do a better job?
Yeah, I totally get where you were going from the start. So I was an intern and also was doing maintenance on conveyors and I mean, was doing it not so rigorously, but yeah, mine shafts. The miners are the miners. It really depends. Some of which one which one is doing what. But yeah, sometimes you can skip. You're going down 3 kilometers. Sometimes, like the biggest ones we've scanned 3 kilometers deep. But of course, you're gonna miss some things at some point because it's 360. It's going down. You might not remember types of things that was there last week, not this week. So this can create lots of potential errors or miss that you don't see. And with our system or with automating mine shafts, you have data that is fully 360 that you can compare from time to time and really see if there's changes and act on that so you're not missing them. Now, so basically, if you're only relating on these human inspections, then you're actually putting yourself at risk that there might be some misses at some point, because we're all going to miss some things.
Tell us how this device works. It's a combination, I believe, of LiDAR and cameras, which is used a lot in mining. But just tell us how those two work together to give us a good inspection of the shaft.
Yeah. So when we started doing shaft inspections, when I really started that company, mobile LiDAR was just starting in the mines, and there was interest from the mine operators to use the LiDAR, but they had lots of issues because first, you don't want to let your shaft to some random technology that there might lose time, might work, might not work. So I decided like, well, I'm going to build something with LiDAR that's going to give you a full 360 3D model of the shaft, and that's going to work fast. It's going to be robust. So I started thinking about that, and contacts I had in the industry were doing visual inspections with a 360 camera, and they had this big setup which gave good 360 video, but it was taking a lot of time. It was complicated to install, and yeah, you would lose a few hours to do these types of inspection. And they came to me, it's like, well, your thing really interests us, but what if you put cameras onto that? So we added like a little head above our LiDARs and put some cameras into that. Like, let's try it. And put some random lightings on that you buy from Amazon. And we tried it, and then we realized that it was much more complicated than just putting lights and cameras. They had lots of types of issues. You're close to the wall. There's going to be blurring. Mine shaft I don't know how it works, but the light you're projecting is going to get absorbed by the walls in some weird, I don't know, like you need to have really, really powerful light. And that's where we decided, well, let's put some effort on also having better lighting. And we all put that together and bundled up in a system that is really tiny, easy to use, and that won't take too much time for the miners to deploy and install. So you were asking me how does it work? So basically there's a station, there's a top station in the mine shaft where there's usually gangways or platform you can put, and you put them above the hole, and there's a rope. It can be one rope or 4 ropes. Sometimes there's different types of skips. And when you go above that, you attach the system onto the rope. You walk onto that gangway. You attach the system onto the rope, put the system in, then you remove that. You start the scanner, so it's going to start recording 3D and visual data and also inertial data. As it will go down, it will record. You bring it back up, remove the gangway, and now you're good to actually start hoisting again. And then our system will process the data, analyze the data on the system itself, and you're going to get your results out of it.
So when a human does the inspection in a mine shaft, I understand it can take something like 8 hours, and you're out of production during that time, which must be costly. How quickly can you do it? Like, how quickly can you get your device onto that cable and and do the scan?
So that's really something that usually mines don't. So when we go to the mine, they say, well, it's going to take you X amount of time depending on your shaft, but usually it's about 30 minutes per kilometer. So depending on how deep is your shaft. And usually they're kind of skeptical and they say, well, we're going to plan a whole day or just the whole morning. And I'm like, no, we're going to make it happen in 30 minutes. And when I come to site, it's like, oh, well, we'll just make sure. So I'm like, okay, anything can happen. So we go to site, and when we start to install the scanner, I always have my my phone and try to meter how much time it's going to take, and really to install it. Just by the time they deploy the gangway, sometimes it takes 5 to 10 minutes. You take that, you put your scanner in under 3 to 4 minutes, then you remove that, and you put it down, bring it back up, and under 30 minutes. And we always check the time. We're making it happen. So 30 minutes per kilometer, that's usually how long it takes.
So if you look at reducing the downtime of a mine shaft from 8 hours to do an inspection manually to a half an hour, what kind of ROI does that give you to buy your technology?
Yeah, well, if you're talking ROI, that's really what mines want to hear when they're putting new technology in their operations. And that's why I decided to go with mine shaft inspection, because the ROI was so potentially big for the mines. And, if you're thinking about it, reducing downtime of a mine shaft or improving their cycle time or whatever you can have impact on that, it's tremendous because it's one of their production bottleneck. So if you're able to produce more, then it's clearly more revenues for the mine. And, quick calculations from gold mines to potash mines and things like that, it can range from $25,000 an hour to $250,000 an hour for downtime of shaft. So we had our first units back then. It was 3D printed, and that guy came in. Usually the guy that works at the mine shaft or the miners doesn't really know how much time it costs when it's shut down. But there was that engineer that came. He's like, yeah, that's $72 a second you're costing us. So if you do the math, 72 times 60 times, that's almost $250,000 an hour. So the ROI can be really, really big if our system get recognized by the laws.
What you were telling me, I believe, is that we can replace the human and the 8-hour shutdown with a machine and a 30-minute shutdown. But in order to really save that time and eliminate the human inspection, we need the regulators to agree that your technology is an adequate substitute for the human inspection. Is that right?
Yes. I think I don't like the term eliminate human inspection, because when we know we won't be able to do what every miner is doing in these inspections, because sometimes there's rocks or things that's fallen. So they need to actually clear out some rocks or do some manual labor, which our system doesn't do. So we don't have robotic arms that can do that. But what we propose is an hybrid solution where there will be digital inspection and sometimes human inspection. But the thing is, we'll be able to flag before the human inspection, so they're going to know where to go and be more efficient and know better about it. So this is really where the laws can, that if the laws agree to that really can have a big impact. But there's an advantage for the mines, of course. So the mines are going to be safe, their shaft's going to be safer, it's going to have less downtime, more production. But for the regulators, at the moment, what they're looking at, if the mines do a proper job at doing the inspection, is a logbook. And it's just somebody signing, putting some notes, might have some pictures, but not too sure. And anybody can actually just say, well, we did it, and just sign it. And if the regulators have access or the proof that these inspections have been conducted, then it's positive for them also. So it's win-win situation for both mines and regulators.
So you get better documentation that the inspection has been done. You have the report that proves it has been done. Because if I was a student doing an inspection, I might be one of those guys who does a poor job and then just writes my name, yeah, it was done. But the part I'm thinking about that is even more interesting is that the same individual, the same human who does the inspection week after week, might have seen a thing or two that the second time they go down, they check on it. They know there was something to take a close look at here. But if a different person goes every week, that experience isn't being shared between them. So I'm thinking when we put down the scanner with the LiDAR and the camera, is there a way to take the data from 1 week to the next and compare them and find what was the change? What changes did we discover from last week to this week? Specifically what they were. Can I see what they looked like? And where were they in the shaft? Do we have that kind of knowledge from the data?
I mean, yeah, totally. But I was going to back up a little bit on what you said about the people that if they're changing, they might not know the differences So basically, in the shaft, when you're spotting something different, what you usually do is you paint it. You give a little paint if you can reach it or if you can see it, and then you might check on it the next week. But sometimes it get lost or whatever. But and the workforce is changing also. So older people are retiring now. There's a new generation coming in, more interested in technology and things like that. And shaft knowledge is something that is really niche and it's hard to transfer if people keep changing like we're seeing now. So that data knowledge and history is super important. Now our system does the comparison automatically. So it gives you a map where you see what we call them meaningful deviation, meaningful changes, and it outputs them, highlights them for you, and say, hey, there might be something there, and you can look at it. And we can even put KPIs, say, there's this amount of changes in this 50-meter slice and this 50-meter slice. So you can see where are the most critical places to actually take care of. So, and that we've recently done that because in the past we did in 2021 some inspections in different mines, and now we came back to really show and showcase where were the changes, and it did work really great. And from a 3D perspective, but also from a visual perspective. So we're doing both the analysis on 3D data for now and working on AI to do the change detection for the visual data also.
Are there examples where after a mine has been running for a while, the shaft collapses or gets some defect that shuts down the mine or kills people?
Yeah, they've been a lot. So we have tons of examples regarding that. It can be, I think there was some events in Sudbury a few years ago. There was a collapse, salt mines also in the United States. Then there can be lots of other types of things, that can happen in the shaft. If you're doing a maintenance and you drop something and then you shut down for a few hours, they drop a bucket or they break things like that. So there's lots of events that shut down the shaft. And there's also tragic event that miners fell down the shaft or while doing inspections or for whatever reason, or the hoist just tripped. And, there's the shaft is the heart of the mine, but it's also how it brings the people to their working places, but how they go back home. And if they can go back home safely, well, then we have a problem. So yeah, there's been tons of examples of shafts shutting down.
So you mentioned salt mines. I understand that when you were thinking about this, you had some experience working in a salt mine. Salt and potash, are they particularly good applications of this technology, or are the shafts basically the same as hard rock?
No, usually soft rock like potash and the salt, they're soluble, so they have lots of problem with water. So if you mix water and salt, then you have some problems. So I was working in a salt mine where we have water infiltration. We need to, what we call regrout it. So I was part of a project where it kind of really how I got into the shaft industry. I got pushed into that project and had to follow up on regrouting and preparing all these processes. So Saskatchewan has lots of potash mines. Then there's also southern of Ontario, where there's our Cleveland area, where there's lots of salt mines also, and we do quite some work with them because they're moving, and we've saw, when we're processing the data, we see some data, and I think the worst mine shaft I saw throughout all the data was from a salt mine. There's big cracks, our heat maps was showing red everywhere. So yeah.
So tell us where you're at with the technology exactly. What have you accomplished? What are you piloting now? And what is the roadmap forward from where you're at for enhancements to it and improvements?
Yeah. So we've started PointLaz 3 years and a half ago. So we're at a stage where we just raised our seed round. So basically, we had a prototype that was working, that looks great. It's the one that we've been running for the last year, and now we're bringing it to production. So we have that production phase where we're going to be more units. So there's lots of small details engineering that we need to put in, but that's where we are, and we're going to release 5 units in September. Now, where we are with our clients, so we did lots of proof of concept around the world. So from South Africa, United States, Ontario, Quebec, Saskatchewan. So, and now they're paid proof of concept. They like the data, but now we're kind of at a point where it's good having investors. It's good building the product. Now we need to put it out there full-time on a full-time base. So that's where we are now, trying to find our first person's going to jump in and say, well, I'm going to use it full-time, and yeah, we're going to make our mine better, safer, and eventually more productive.
So since I met you, we had been talking about your technology with a number of our members, and 3 had expressed interest in participating in some way in a consortium. And perhaps as we talk with a few more members, others will want to join in. So I'm imagining an ideal pilot for you would be something where it's a full-time deployment, where it's being used every week by the people who work in the mine, and they're giving you feedback on, is there glitches, what was their experience? Tell us what you would be trying to accomplish with this first full-time deployment.
When the LiDAR started in the mines, people didn't really know how to use the data and value this data. Now we're seeing autonomous drones flying everywhere in the stopes, and engineers cannot work without them as CMS or older things now, and now they have more precision. And that's what we're hoping to get now. Is we have some use cases, but I'm pretty sure that if you use the device on a regular base, there's going to be much more use cases and value out of it. And we want to prove this value and really have the feedback from the clients. Like you said, also, that user feel that use them on a weekly basis really give us great feedback on how to actually present the data and give the data to the clients. Because when we started, we gave point clouds and 360 videos. But if you don't know how to use a point cloud and you have that 3 kilometer long point clouds, that's, I don't know how much gigabytes, you're not going to get value out of it. What are you going to do with it? So there was these guys, which I really like. They're based in Saskatchewan. So it's unroll the point cloud and do some heat maps with it and give us where are the problems. And we did that. And now we're giving out PDF reports that anyone can use and open, take notes. So you give that to a miner, he can use it, to general manager. So there's no really lost time on trying to understand and what's going on and what's not. So we've put lots of effort on giving the value of the data to the clients directly and making it easier for them.
And if you had the participation of, 3 or 4 mining companies, all giving attention to this deployment, giving their advice, their feedback. What role could those mining companies play in helping shift the regulations to allow this to be used for regular inspections? Like, what role would they play? How would they contribute exactly?
They would play, of course, a great role. I think if you want to change some laws, you need to have some arguments, but you need to have the industry that's willing to put some effort into that. Well, we're not blind. We know this process can take time, but it happened in the past. If you know EMT, which is electromechanical testing, they're putting a little thing around the road, and they're checking with electromagnetic fields if there's problems within the road. Now, these systems were now mandatory in the laws, and it was changed in South Africa, but now we're seeing the same amendments in the laws in Quebec, in Ontario. So, but these things take time, and we need to be backed by the industry saying, well, we want to put effort into that to make our mines safer and more and produce more. But there also needs to be some money put into that, into the project, into making it happen. And I'm not talking about R&D and development. I'm talking about buying that thing. So we need to have like buying that thing, putting it out, having some proof data, having some recurrent some data that is coming that's going to prove the regulators. And from the get-go, we want to have the regulators that are involved in the process so they can ask what they want, what they would do. So it's kind of a whole melting pot, but this takes time and help from all the players, whether it's the industry, the regulators, or the developers like us.
I think it was you who told me that without participation from mining companies, the regulators have no appetite to discuss it whatsoever. There's just not sufficient evidence to them that they shouldn't spend any time on it. Is that right?
Yes, well, it is, but they got, so from my understanding, so there's safety committees that happens each year, and then these committees, there's mine operators, there's regulators, and then they put on the table what are the priority for the year, what project do they want, what law change do they need to actually address. Now, as an entrepreneur, you cannot sit on that committee, so you need to have people from both sides, from the regulators and the mines, to actually sit on that and say, well, that's something we want to pursue. And that's how you get that started.
So I understood from you, our conversations initially, that with your technology, we can improve, enhance the shaft inspection. And when I think about the shaft, I'm thinking about the walls of the shaft. Looking for defects, looking for changes. But there was something else you mentioned, which had to do with inspecting the alignment of the guides. Tell us about guide alignment. Why is that important? What difference does it make? And what your plans are in that area?
Yeah, so a guide, just I talked earlier about it, but it's the railways that direct the conveyance, whether it's a cage or skip, going up and down. Now, these skips are really, really heavy, and they're going up and down at fast rates. So the faster you're going, the smaller the cycle time is, and the more production you're going to get. So you're trying to go as fast as possible, as it was designed initially. So sometimes we see lots of mines increasing the size of their skips, changing their guides from wooden guides to metal guides, trying to go fast. But one of the problems that you can address directly is sometimes the guides tend to wobble a little bit, and that's what we call misalignments. And these misalignments impact the skips because they need to slow down. If not, they're going to have some big impacts and big problems going to be related to that. So their cycle time needs to be reduced, and this creates problem. Now, they're trying hard to make them as straight as possible. There are ways to make it, like plumb bobs or other types of systems, but it takes time, and that's create shutdowns, which is also a problem. Now, what we had lots of requests from the mine saying, hey, we want to get precision, we want to get these alignments. But as we're speaking now, mobile LiDARs are only achieving 1.5 to 1 centimeter precision, which is not enough for the mines to realign these guides. So we had a project, was one of the first one of our clients. He put a bit of money into that to that project. Say we want to try to align these guides. So we built some kind of custom device, out of the shelf sensor, tried something which had great result, but we were not able to get that millimeter precision. Now what we're trying now is there's other types of systems that we want to design to get that millimeter precision and really be able to help the mines reduce their cycle time and improve their production.
I thought the idea of changing an 8-hour shaft inspection to a half-hour created a financial case that was like a slam dunk. But if you talk about aligning the guides and reducing the cycle time and increasing production, that's probably even a stronger financial case for this. Is that right?
Yeah, of course, it's stronger financially, and also there's big safety impacts that we still want to hammer the nail onto it. Is that it's not only good for your money, but it's also safer for your miners. So yeah, there's lots of advantages with our systems that are now available, and as we will build and grow our company, we will continue to develop technologies that will make even bigger savings for the mines.
So to undertake this development of this precision guide alignment, you would need a little help from a mining company, a participant, some cash, probably, right?
Yeah.
But what you told me is that you've been really successful in taking modest amounts of cash and multiplying them through grants and loans. Is that sort of thing still available to you if you have a mining company who's interested in supporting?
Yes, of course. So the reason why PointLaz was here is we were able to leverage some little money. So we had little projects with the mines, and let's say a $30,000 project would help us first get some grants. So if you get grants, I think Government of Canada and Quebec and also Ontario, lots of provinces also offer different grants, which really helps us develop. But these grants, they're not give away free money. You need to actually spend it and then get paid back. So for that, you need to have money in your bank. And if there's a mine that does appeal for us, then it's easier to say, well, to go to the bank and say, hey, can you loan me that? Because there's interest, and they're going to be more happy to loan, and and then you get that ball rolling. So from a $30,000 project that we had for the guide alignments, we ended up putting $150,000 total. So yeah, we're really, really good at leveraging this money and improving our technology and making it happen. So yeah.
So Alexander, at ReThink Mining, our goal is to take young companies who have promising technologies and help them move forward by getting the mining companies to work together so that they can participate, learn about your technology, trial it with lower risk. What I'm hopeful about your technology is that this group who have been getting together to talk about automation and underground mining, that they're going to embrace it. We have the documentation being put together right now that will allow them to form a consortium around automation and underground mining. And I'm hoping that they find your technology as interesting as I do. So in the coming months, I think we're going to find out. And I wanted to thank you today for spending your time with us and sharing this first step forward for automating underground mining.
Yeah, well, it was a pleasure, Don. Really happy to see you again. Not in person this time, but yeah, thanks for the time, and really hoping hard that this consortium could work and make it happen.
Thanks very much. We'll see you again.
All right, thank you.